back. Today we shall be looking at Cambridge A-level exam Mathematics 9709 paper 3 variance 3 May June 2023, as you can see. Now the first question is this. The first question solve the equation. It's a logarithmic question anyway. That's like the first topic, the syllabus or so. This is the second topic in the syllabus after algebra. So we have to solve these 3 decimal places. Before I proceed, I would like to call your attention back to the laws of logarithms. Remember, if you have something like this, lane x minus lane y, it simply means lane x over y. Take note of that. I want to highlight the rules we need to solve this question. And also, if you have y lane x, it simply means lane x raised to power y. And also, if we have a situation like this, lane A, or lane, let me continue with my x. Sorry, I need to change this color. Or if you have lane x equal to y, it means that this x equal to e raised to power y. That's the meaning. So, and also take note that lane, let me write it down, lane alone, let's say lane x, is the same thing as saying log base e to x. Okay, take note of those information. And let's go back to the question. Lane x plus 5 equal to 5 plus lane x. Okay, it means lane x plus 5, bring the lane to the other side here, minus lane x equal to 5. Remember this rule, this one underline. So lane x plus 5 minus lane x. Obviously it means lane x plus 5 over x equal to 5. Remember I said lane is the same thing as saying log base e. So I've interpreted lane. Don't forget to write the x plus 5 over x equal to 5. Remember what happened here. When lane x equal to y, x, the one beside lane, is, when you bring it out, it's e raised to power, the one on the right hand side. So when you bring x plus 5 out, x plus 5 over x is going to be equal to e raised to power 5. Cross multiply. When you cross multiply, we have x e raised to power 5 equal to x plus 5. Now we arrange your equation. So when you arrange, as in collect the like term, we have x e raised to power 5 minus x equal to 5. Factorize x into bracket e raised to power 5 minus 1 equal to 5. So find the value of x by making x the subject of formula. That will be 5 over e raised to power 5 minus 1. So what's the value of x? Punch it into your calc. 5 over e raised to power 5 minus 1 give us 0.034. So 3 decimal places. 3 number after decimal number, after decimal point. That's it for the first question. Now for the second question. We have to find the quotient and remainder. This polynomial. We have to find quotient and remainder. So let's divide this by this. So you have to divide 2x raised to the power 4 minus 27 divided by x squared plus x. Okay. Let's follow our polynomial rules. Let me check the space. Okay. It's quite reasonable. We want to divide 2x raised to the power 4. Let me write down first. Now, after 2x raised to the power 4, to make it easier, it's supposed to be a number of power of cube, but there's nothing like power of cube, so put it as 0x cube because there's nothing like that. After cube, it's supposed to have square, but it's not like that. It's not there. Put it, since it's not there, you put it as 0x squared. After x squared, you know, polynomial form, it's supposed to have x, but it's not there. Put it as 0x before a constant, which is 27. That is there. We're going to divide it by x squared plus x plus 3. So what do? 2x raised to the power, the first step is 2x raised to the power 4 divided by x squared. What do you have here? 2x squared. The next step, this 2x squared, you multiply all this divisor. We use to multiply this divisor. This is the divisor. So 2x squared multiplied by the divisor back. Your answer times divisor back. That's always it. 2x squared times x squared. We have 2x raised to the power 4. 2x times x. That's 2x cubed. 2x squared times 3. That's 6x squared. That's it. We multiply by 3 of them. After that, we subtract. Then you subtract this. 2x minus 4. 2x is power 4. 2x 0. 0x cubed minus 2x cubed. What do you have? Minus 2x cubed. 0x squared minus 6x squared. What do you have? Minus 6x squared. 0x, there's nothing under it, return it back. Minus 27, there is nothing under it, return it back. Now repeat the first step again. Minus 2x cubed divided by minus 2x cubed divided by x squared. What do you have? That's minus 2x. Like I said, repeat the first step again. After getting your answer, you now use your answer to multiply all the divisor again. So minus 2x times x squared. That's minus 2x cubed. Minus 2x times x. That's minus 2x squared. Minus 2x times 3. That's minus 6x. You are done with it. Do another subtraction. Minus 2x cubed minus 2x cubed. This one is 0. This side is 0. Move to the next one. Minus 6x squared minus 2x squared. To give you minus 6x squared plus 2x squared. That will give you minus 4x squared. 0x minus 6x. That's plus 6x. There's nothing under 27 to bring it out. Minus 27. So we repeat the process again. This is the first step. Minus 4x squared divided by x squared. We have minus 4. Minus 4 times the quotient, the divisor again. That will be minus 4x squared. Minus 4 times x. Minus 4x. Minus 4 times plus 3. Minus 12. Subtract. When you subtract, this one is out. 6x minus 4x. That's 10x. Minus 27 minus 12. That's minus 15. We're going to stop here. Do you know why I'm going to stop here? Because 10x over x squared will give us 10 over x. It's not a whole number anymore. So we stop. So that's it. But you have to find the remainder. The remainder is your answer. The answer here at the bottom. So the remainder is what is here at the bottom. 10x minus 15. We also asked to find the quotient. Check the question. You have to find quotient and remember quotient is what is on top. Quotient is this. Quotient is this. This is the quotient. So 2x squared minus 2x squared minus 2x minus 4. That's the quotient. That's it. Next question. Complex number. Okay. Sorry, I have to recharge my laptop. Okay. If you have something like this, um, like from inequality, for example, you need to square both sides. That's the meaning. Remember that z is x plus iy. Z is x plus iy. Z is x plus iy equal this z is also x plus iy minus 4i. So we have x plus iy equal. Now we arrange this. X plus I into bracket y minus 4. So this is what we have. Remember, when you have two modulus equal to each other, you square both sides. At the same time, minus squaring both sides, modulus of x plus iy, what does it mean? It means x squared plus y squared. Modulus of this also means x squared plus the imaginary of this one is y minus 4 squared. So x squared here cancel x squared. What do you have here? Y squared. When you expand y minus 4 all square, I think it's going to give us y squared minus 8y plus 16. So when we arrange, at the end of the day, we have this cancel this. So 8y is equal to 16. So what is our y? Our y equal to 2. Now, we have deciphered or delocalized the two equations. Now, you can see this one is a line. This one is a line, which means gave us just y equal to 2, which means this equation here is a line, while this one is a locus, is a circle, because it has a center and a radius. So now we're expected to sketch that. Let me see whether we have space down to do that. I think there's space to do it here. Let's sketch it. Okay, I think I can use this side. Let's sketch it here. First, this is my line. Don't mind my accuracy of the straight line. Just follow what I'm saying and the way I sketch there. This is 0. Remember, we have the center is 3 and 1. X is 3. 1, 2, 3. When x is 3, what's y? 1. That's the center. And what's our radius? Let me check it properly. Our radius is also 3. Now, remember, if the radius is 3, the edge, radius is center to edge. Center to edge here, it should be 6. That's 3 units to the right, 3 units to the left. That's 1, 2, 3. 3 units upward. That's 1, 2, 3, 4. 3 units upward is 1 to 2 is 1 unit, 2 to 3 is another unit. 3 units upward, that's 4. And 3 units downward. 1 to 0 is 1 unit. 2 minus 1, 2 units. 2 minus 2, 3 units. Yeah. So if you're going to sketch it, so which means that it should look like this. It will look like this. Don't mind my diagram. If you check it, I think 3 units upward stop at 4. The circle cannot pass 4, cannot pass 6, cannot pass 0, and cannot pass minus 2. So this is a perfect locus. This is it. So now this is the locus. The second one is the line y equal to 2. Remember, this is y-axis and this is x-axis. Y equal to 2 will be a straight line on y equal to 2. Okay, where are we going to shade? I remember the sign. Now this is when you now use this is greater than. If it's greater than, for the line is greater than, which means it's going up. Greater than is going up. Now for the circle, let's say it for the circle is less than, right? Circle is less than, which means for the circle inside the circle is less than. So this is a line to the circle, and so it's coming down for the circle. It's coming down. So this is the region we want us to shade, the point of intersection of the sign. That's it. Question? You can comment, put it down in the comment section if you have any question. I think that's what they asked us to do. You have to sketch sketch the inequalities on the same graph. So that's it. Number 4, parametric equation. Now we have, let me check this first. Actually, it's quite fair. We have x equal cos theta over 2 minus sine theta. In this case, we can only find the x, the theta. before I do that, you can only find the x, the theta. You can only find the x, the theta using quotient tool. This is numerator, this is denominator. So using quotient tool, you differentiate the denominator. Wait, hold on. Let me write it. Okay, if I'm going to use quotient tool in this case, you put down the denominator, okay, the x, the theta. Put down the denominator, don't touch it. That's 2 minus sine theta. You're going to rewrite it, don't touch it. Then differentiate the numerator. You're going to differentiate cos theta minus, now interchange them. Put down the numerator, don't touch it. Then differentiate the denominator, 2 minus sine theta, all over the denominator all square. This is called quotient tool. It's called quotient tool. So the x, the theta will be, the x, the theta will be, the x, the theta will be, now 2 minus sine theta. When we differentiate cos theta, what do you have? When you differentiate cos theta, what do you have? Minus sine theta. Minus cos theta. When you differentiate 2 minus sine, when you differentiate 2, that's 0. When you differentiate sine theta, that's cos theta. All over 2 minus sine theta all square. Hence, the x, the theta will be, open the bracket by minus sine theta. So when you open the bracket by minus sine theta, what do you have? You're going to have minus 2 sine theta minus 2 sine theta plus sine squared theta. Here, 0 minus cos theta is minus cos theta. Minus cos theta times minus cos theta, that's plus cos squared theta, and you multiply them. All over 2 minus sine theta all square. I remember that sine squared theta plus cos squared theta is 1. So hence, the x, the theta will be 1 minus 2 sine theta over 2 minus sine theta squared. That's the x, the theta. Now, that's one of the functions. The other function is y. I can do that here. Remember that y is theta plus 2 cos theta. I can only get the y, the theta here. The y, the theta here will be, when you differentiate theta, that's 1. When you differentiate cos theta, that's minus sine theta. So this will give us minus 2 sine theta. This is the y, the theta. And this is the x, the theta. But what we are looking for is the y dx. Don't forget that the y dx will be the y, the theta, times the theta, the x, such that when you cancel the theta, we have the y dx. So the y dx will be, what's at the y, the theta? If you remember, at the y, the theta is 1 minus 2 sine, 1 minus 2 sine theta, that's at the y, the theta, times the theta dx will be inverse of this one. So this one is the x, the theta. Theta dx will be 2 minus sine theta all square over 1 minus 2 sine theta, which they can cancel out. So at the end of the day, what left for the y dx? So the y dx will be 2 minus sine theta all square. I think that's what they asked us to prove. Yeah, y dx 2 minus sine theta all square. Question 5. The diagram shows the path of the curve y equal x squared cos 3x. This is the curve. The value of x is between 0 and 1/6 pi. As you can see it on the screen, the maximum point is n, where x is equal to a. Yeah, when x is a, at that point, that's the maximum point. Show that a satisfies this equation. Now, since they mentioned maximum point, remember that a is the value of x at the maximum point, which means indirectly they asked to find the value of x at the maximum point. So, what's the equation? The equation is y equal x squared cos 3x. Remember that at maximum or minimum point, the y dx is always equal to 0. That's the stationary point. But they've already tell us the nature of the point is maximum. You don't need to test it anymore. So here, we're going to apply product 2. In product 2, put down the first function, differentiate the second function, plus put down the second function, differentiate the first function. So at the end of the day, the y dx will be x squared. When you differentiate cos x, that's minus sine x. Oh, it's cos 3x, sorry. Cos 3x. Cos 3x. So when you differentiate cos 3x, it's different. Let me give you the guidelines for that. Now when you differentiate sine kx, it's going to give you k cos kx. And when you differentiate cos kx, it's going to give you minus k sine kx. That's it. So when you differentiate cos 3x, it's going to give you minus 3 sine 3x, where k is an integer. It can be any integer. It's a number, either whole number or fraction. So plus cos 3x. When you differentiate x squared, what do you have? 2x. Remember that maximum point, the y dx is 0. So we're going to put this to 0. We're going to put minus 3x squared sine 3x plus 2x cos 3x. Put it to be 0. And I think x is common here. So divide through by x. Divide through by x, or at the same time, okay, let's rearrange. Let's do like this, minus 3x squared sine 3x. Let's put this one to the other side, become minus 2x cos 3x. So minus, they cancel. What left? 3x squared sine 3x equal to 2x cos 3x. Since what we have to prove has tan, so how can we get tan in this place? You can only get tan when you divide both sides by cos 3x. Divide both sides by cos 3x. So it gives us 3x squared. Sine over cos is tan, and the function is 3x. Tan 3x equal to cos 3x cancel cos 3x. So what do you have? 2x. So make tan 3x the subject of the formula. What do you have? 2x over 3x squared. 3x squared is 3x times x. 1x cancel x. So we are looking for x. First, bring 3x out. To give arc tan 2 over 3x. So make x the subject of formula. X will now be 1 over 3 arctan 2 over 3x. Remember from the question that x is equal to a. So therefore, a will be 1 over 3 arctan 2 over 3a. That is what the question asks us to play with. The next question, B. Use an iterative formula based on the equation we just derived now to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now, the model for the iteration is this. The model for the iteration is 1 over 3 arctan 2 over 3a. That's the model for the iteration. Remember the questions, we are given domain in the question. The domain for x is between 0 and 1 over 6 pi. And x is the same thing as a. So 0 less than equal to a less than. So this is the domain for a. In iteration, you need the initial value, as in a1. Since you are given domain, the initial value can be obtained by finding the average between 0 and 1 over 6 pi. Find the average. The average gives us pi over 12. So a1 will be pi over 12. That's the first one. Don't forget, when you are doing iteration, your calculator must be in radian. When you are doing iteration, it must be in radian. Now this model is like this. You can write it like this: an plus 1. If this a turns to an plus 1, the a inside will be 2 over 3an. That's the whole idea. So let's find a2. We have a1. The next one is a2. As at a2, n is 1. When I'm saying a2, this n turns to 1. As at a2, n is 1. So we are talking about 3a1 when you are dealing with a2. So what is a1? a1 is pi over 12. Substitute a1 inside. Substitute a1 there. So a2 will be 1 over 3 arctan 2 over 3 times a1. a1 is pi over 12. a1 is pi over 12. So put this in your calculator. Make sure it's in radian. Let's punch it. You're going to give us 0.39887. I like putting it in more than 4 decimal places to be sure what I'm doing. Let me get a3. To get a3, it's going to be 1 over 3 arctan 2 over 3. When you're talking about a3, what we hear is a2. And we have our a2 to be, so it now be 1 over 3 arctan 2 over 3a2. And a2 is 0.39887. Make sure your calculator in radian is important, or else it's going to get one answer. So a3 will give me 0.3439. Let's get a4. Remember that when you are getting a4, what is inside of a is 2a3, and we have a3 previously. So you're going to have 1 over 3 arctan 2 over 3a3, and a3 is 0.3439. Make sure your calculator is in radian. It's key. Or else 0.3648. Okay, let's see whether we are having, there's no similarity. In 2 decimal places, this is still 0.4. This is 0.34. This is 0.36. There's no similarity. Once we have similar number in two decimal places, then we are heading toward the answer. A5. For A5 is 1 over 3 arctan 2 over 3A4. And we got A4 in the previous one. So that will be 1 over 3 arctan 2 over A4. A4 is 3 times A4, 0.3648. So for A5, we have 0.3567. It's looking similar. This is 0.36, this one is 0.36. Let's confirm it. It's going to be the same. A6, we know what to do with A6. What will be inside will be A5. 2 over 3 times A5. And A5 is 0.3567. So I punch it in calc. I think it gives me 0.3598. In two decimal places, we have 3 consistent values. Hence, we can conclude and get our value of iteration to use our iteration formula to determine A to 2 decimal places. So the final answer, which means our actual A, is 0.36. That's it. Our iteration is 0.36. Number 6. Express 3 cos x plus 2 cos x minus 60 in the form of r cos bracket x minus alpha, where r is positive because it's greater than 0, alpha is in between 0 and 90. State the exact value of r and alpha to 2 decimal places. Okay, let's do it like this. 3 cos x plus 2, cos x minus 60. What does it mean? It means cos x cos 60 plus, check your trig compound angle, double angle formula, you know what I'm doing, plus sin x sin 60. So this is 3 cos x plus, open the bracket by 2, 2 cos x cos 60 is half, plus 2 sin x sin 60 is root 3 over 2. At the end of the day, we have 2 cancel 2 here, 2 cancel 2 here. So 3 cos x plus cos x. At the end of the day, we have 4 cos x plus 4 cos x plus root 3 sin x. That's it for this expression. But the question asks us to do it in form of this, r cos x minus alpha. So let's express 4 cos x plus root 3 sin x in form of r into bracket r cos x minus alpha. That will be r into bracket cos x minus alpha means cos x cos alpha plus sin x sin alpha. Open the bracket. This is 4 cos x plus root 3 sin x. Open the bracket by r. It gives us r cos x cos alpha plus r sin x sin alpha. Now, we are going to equate the coefficient from here. 4 cos x can be the same, as r cos x cos alpha, because they have the same coefficient, cos x cos x. So hence, r cos alpha is equal to 4. I call it equation 1. the same time, with 3 sine x, can also take position of r sine x, sine alpha. They have the same coefficient, sine x, sine x. So I can say r sine alpha equal to root 3. I can call it equation 2. But the question asks us to find r and alpha. For me, I can get alpha first. To get alpha, I can divide. Let me divide equation 2 by 1 so I can get something of tan. Equation 2 is r sine alpha. Equation 1 is r cos alpha. And equation 2 is equal to root 3 here. 1 is equal to 4. R cancel out. Sine alpha over cos alpha. That's tan alpha. Root 3 over 4. That's 20. Root 3 over 4. Okay. Equal to root 3 over 4. What is alpha? Alpha is arctan root 3 over 4. Punch it in your calc. We have 23.41 degree or 23.4 degree. That's alpha. So let's get R. To get R, okay, since we have alpha, okay, substitute alpha in either equation 1 or 2. Let me use equation 2. Anyone? Equation 2 is R sine alpha, and alpha is what? 23.4 is 41. I just approximated to that, equal to root 3. So what is R? R should be root 3 over sine 23.41. Let's punch it in a calculator. Root 3 divided by sine 23.41. We have 4.359. So our R is 4.36 as the value. I believe it's clear. Let's see the next question. Hence, so which means that, okay, which means that we have our R, which means that 3 cos, I'm writing the question, 3 cos, this is the question, 3 cos x plus 2 cos x minus 60 plus 2 cos into bracket x minus 60. So she write it in this form. R cos x minus alpha. R is 4.36 cos x minus alpha. And alpha is 23.4. So this is what they asked us to do. We've converted this form. This is what they asked us to do. I've converted this form to this form. That's what they asked us to do. Next question. Now, hence solve the equation 3 cos 2 theta. Oh, if you check this equation, it's a bit similar to the original question. Original question is 3 cos x plus 2 cos x minus 60. The only difference is that where you see x has turned to 2 theta, that's the only difference. Where you see x, they put 2 theta. So if you're going to be smart about it, we can say that the question they asked us to do 3 cos 2 theta plus 2 cos 2 theta minus 60 will be the same thing as this. As the form it does will be 4.36 cos. The only difference is that x has turned to 2 theta. 2 theta minus 23.4. That's it. That's the scope. And at the end of the day, it's equal to what? 2.5. which means I'm going to equate 4.36 cos 2 theta minus 23.4. I will equate it to 2.5. That's the logic. So you have to find theta, and theta is between 0 and 180. So let's do our normal routine. Cos 2 theta minus 23.4 will be equal to 2.5 over 4.36. So 2.5 over 4.36 will be 2.5 over 4.36. Okay, now let's find this one. So hence 2 theta minus 23.4 will be arc cos of this. So 2 theta minus 23.4. This is how we do it. Inverse of this give us 55 degrees. Now after this step, check our cast where cos is positive. Cos is positive here, and the formula here is what? 360 minus theta. So the net value here will be 360 minus 55 because our theta is 55. So 2 theta minus 23.4. 55 is the principal angle. The other one is 360 minus 55. That gives us 305. Hence, 2 theta will now be 55 plus 23.4, and also 305 plus 23.4 when it goes to the other side. So hence 2 theta 55 plus 23.4, that's 78.41. 305 plus 23.4, that's 328.41. So divide both sides by theta. So theta will be 70. So divide both sides by 2. Sorry, 78.41 divided by 2. 328.4 divided by 2. So 2 cancel 2. So our theta will be 39.2 degree and also 164.2 degree. We are getting 2 angles because the function of theta is 2. If the function is 3, you get 3 angles. That's the logic. Next question, number 7. So put u to be cos x, show that this is this. Okay. They ask me to put u to be cos x. Let me do it here so I can manage the space. Because of this, there's dx here. I must differentiate this because of that dx, so I can get something like dx. U dx will be minus sin x. When you cross multiply, the u is minus sin x dx. Make dx the subject of formulate to be the u over minus sin x. That's one step. The other step, you can see that the limit has changed. It's pi here, pi and 0 is now 1 and minus 1. Okay, let me do it here. Since our u is cos x, we have the value for x, but we don't have the value for u. I mean the limit. The first limit when x is pi was u. Was cos pi. Cos pi give me minus 1. U is minus 1. So when x is pi, u is minus 1. Because this side is about u. This side is about x. This is about u. This is about x. Now when x is 0, what is u? That will be u equal to cos 0. cos 0. What's cos 0? I think cos 0 is 1. When x is 0, u is 1. Are you seeing what I'm saying? This pi here for the x limit, for the x region, this pi is an upper limit. By the time I change it to u, it has turned to lower limit. This x is, when x is 0, is lower. By the time I change it to u, it's now upper. Something like this. B, if b is higher here and a is lower for a function of x, you can see by the time we do our substitution, the upper limit here is now lower limit for the other function, that's function of u. And the lower limit here is now upper limit for the function of u. In that case, here will be negative. That is the rule. Let me write it. The rule states that former upper limit of a function, when it's swapped to something like this, it will change, it will be negative. Okay, I think that's the key. So now let's solve it. Let's do what they ask us to do. So hence integral, let me demarcate it so there will be no confusion. Demarcate, cause of confusion. Now integral pi 0 sine 2x. You know this sine 2x. Sine 2x means 2 sine x cos x. E raised to power 2 cos x. That's 2u. U is cos x. Multiplied by dx. And what's our dx? Our dx is 2u over minus sine x. You can see we've done this properly. And so sine x cancels sine x. What else again? So we now have, remember that by the time you put u, this pi and 0 no longer exist because we've turned pi and 0 to 1, now minus 1. Like I said, from this rule, here will be minus. So what do you have now? We have 2 cos x. Remember, cos x is u times e raised to the power 2u multiplied by 1 over minus 1. No, du over minus 1. So now this minus and this minus, they work and cancel out like positive, right? So what do we have now? So we have 1 minus 1, 2u e raised to the power 2u du. I think this is what they asked us. Sorry, I managed space. I don't know the space will be enough. This is what they've asked us to prove. I believe it is clear. Let's move to the next one. That's what they asked me to prove. Next one. Now, and find the exact value. Remember that this equation, or this equation is already integral of 1 minus 1. What we proved earlier, 2, I think it's 2u e raised to the power 2u du. The equation is now like this. So now, when you arrange the equation, let me bring the 2 out. So you have the variable inside, 1 minus 1. So you have u times e raised to the power what? 2u du. So you want to integrate product of two functions. When you're integrating product of two functions, you have to use integration by parts. What do you do? uv minus integral of v du. That's integral by part. U is the lighter function. V is the kind of function or complex function. So in this case, now, fortunately, our U is U in this space. Is the lighter function, which is U. The other function will now be the V. The V is U raised to 2U. Let's assume you use the function of x. Use the function of x. So the U dx is 1. It's as if this U is as if is x. The U dx is 1. That's just how it looks like. So the U dx is 1. This is the V. To get V, if you have the V to get V, you are reversing back. You need to integrate. Integral of the V, integral of e raised to power 2u. So from here, so the U dx is 1. When you integrate the V, it is V. You're going to get. Integral of e raised to power 2u means e raised to power 2u over 2. Let me just give you the constant. If you have forgotten, when you integrate e raised to power kx, it's going to give you e raised to power kx over k. That's it. Now, substituting this in part form, let me see this space. It should be enough. We call that integral using, so we call that integral by part is uv minus integral of v du. What's our u in this case? Our u in this case is u. Our v is e raised to power 2u over 2 minus integral of v. Our v in this case is e raised to power 2u over 2, while the u is 1. So at the end of the day, we have half u e raised to power 2u minus, this function can be written as, we can bring 1 over 2 out. What left in? E raised to power 2u. Check it properly, see it's right. So we have half u e raised to power 2u minus half. So when you integrate e raised to power 2u, what do you have? E raised to power 2u over 2. So at the end of the day, we have half u e raised to power 2u minus 1 over 4 e raised to power 2u. That's it. Don't forget we still have a limit, 1 and minus 1. And don't forget there's still 2 outside. Check it. Look at this 2. It's still outside. So open the bracket by 2. So at the end of the day we have u e raised to power 2u minus half e raised to power 2u. Don't forget our limit, 1 and minus 1. So let's put it there. When u is 1, that will be 1 times e raised to power 2 minus e raised to power 2 minus. When u is minus 1, that's minus 1 times e raised to power minus 2 minus half e raised to power minus 2. And so here we have e squared minus half e squared. E squared minus half e squared, we are going to have half e squared. It's like 1 minus half. This space, open the bracket by minus. Minus times minus plus e raised to power minus 2 plus half e raised to power minus 2. So this one is just like 1 plus half. That's 3 over 2. So we now have, after this point, so the answer is half e squared. This plus this, they have the same coefficient. That will be plus 3 over 2 e raised to power minus 2. You can leave your answer in this form. It's not necessary to put in decimal. If you put in decimal, it's also correct. That's it. Any question in the comment section is welcome. Now, this differential equation, the variables x and y satisfy the differential equation. The y dx equal to y squared plus 4 over x into bracket y plus 4. For x greater than 0, it is given that x, when x is 4, y is 2, 3. Solve the differential equation to obtain the value of x when y is 2. Obtain the value of x when y is 2. Okay. You all know the drill about differential equation. It's about separating the variables. What do I mean by separating the variable? Function of y must go with the y. Y function of x must go with the x. At the end of the day, you integrate both sides. That's it. First, you must separate both sides. And so, how do you usually separate both sides? See what I can see here. I can see that the equation can be written like this. The y dx can be written like this. 1 over x times y squared plus 4 over y plus 4. I think you should agree with me. They are the same thing. So, since they are the same thing, then let me make let's separate the variable here. How do you do that? This equation, I think, can be written as, okay, let me multiply both sides by the x. Multiply both sides by the x. Multiply this by the x, and this, I said both sides by the x. So the x cancel the x. What is left here? The y equal to 1 over x times y squared plus 4 over y plus 4 dx. Now, what is odd in this place? What is odd is the function of y. So let me take it out. So divide both sides by y squared plus 4, because it's extremely odd. Because everything must be in order: y to y, x to x. So this cancels this. Now, let me see how many pages. 2 pages. Oh, we're good to go. So at the end of the day, so we have the y over y squared plus 4 over y plus 4 equal to 1 over x dx. Yes, I think the variables are together now. So the y over y squared plus 4 over y plus 4, it's the same thing as saying y plus 4 over y squared plus 4 dy equal to 1 over x dx. Okay, great. From here, we can now integrate both sides, because this is the y, sorry. Y is attached to the y. X, function of x, is attached to the x. We can now integrate both sides. Okay, how can I integrate y plus 4 over y squared plus 4? Okay. If you agree with me that this is a bit technical and simple, y plus 4 over y squared plus 4 can be the same thing as y over y squared plus 4 plus 4 over y squared plus 4. I'm very sure you should agree with me. To find the LCM, which is y squared plus 4, it's going to give you back this. Equal to integral of 1 over x, it's constant. It's in x. Don't forget, they are arbitrary constants. Now, how do you integrate y over y squared plus 4? This thing means integral of y over y squared plus 4 plus integral of let me bring 4 out. What it means is 1 over y squared plus 4. The same thing. There's the y. There's the y equal to ln x plus c. Let me divide our stuff into 2. So we should be able to maximize the work and the space, so the second page will be also enough for us to show our skills. Now from here, let's integrate this. It look, there's an integral like this. Um, this one, I put one dot. This one I put one dot. Let's integrate it. The only way I can integrate the one I put one dot is this. When you differentiate the denominator, okay, I'm very sure you know this, that the denominator, I'm very sure when you differentiate the denominator, it gives you the numerator. It gives us lane of the denominator. Sorry, when you differentiate the denominator, it gives you the numerator. The answer will be lane of the denominator. So when you check this, I mean y over y squared plus 4. When you differentiate the denominator, it's supposed to give you 2y. Unfortunately, the numerator is not 2y. So let me amalgamate by putting 2 here to make it 2y. I've scattered the equation if I put 2 here. To balance it, I must put over 2 outside. So at the end of the day, when you differentiate the denominator, y squared plus 4, it gives you numerator. So our answer will be 1. The answer will be 1 over 2 lane. Sorry. The answer will now be 1 over 2 lane of the denominator. That's how to integrate such function. Now, the other one is the other integral is 4 over y squared plus 4. Let's integrate that too. We want to integrate 4 over y squared plus 4. It's also the same thing as saying 4 integral 1 over y squared plus 4. When you check your MF19, you see something like this, integral like this. You see that when you integrate is in your MF19. When you integrate 1 over x squared plus a squared, we have 1 over a arctan of x over a. Is at the back. It's on MF19. So I can see similarity in it with this. Don't forget the 4 at the back. I'm coming. 1 over y squared plus 4. 4 can be expressed as 2 squared. X squared is like y squared. A squared is 2 squared. If you follow that format, it's going to give us 1 over 2. I'm very sure you're following it. It's going to give us 1 over 2 arctan of y over 2. So remember, there's 4 at the back. So multiply your answer, the result, by 4. So we have this. So at the end of the day, 4 times half is 2 arctan y over 2. So at the end of the day, the integral of y over y squared plus 4 plus integral of 4 over y squared plus 4, I mean the left hand side of the function we are dealing with, give us 1 over 2 lane y squared plus 4 plus 2 arctan y over 2. That's the left hand side integral, give us that. So now let's now go further. So since the left hand side already give us half. The left hand side already give us half lane y squared plus 4 plus 2 arctan y over 2, and the right hand side is ln x plus t. Hope I'm not missing out anything. Let me check. Okay, so the next thing is to find the arbitrary constant. The first condition is when x is, let's check. The first condition is when x is 4, y is 2 with 3. So we can get the arbitrary constant from that first condition. When x is 4, y is 2 with 3. X is 4, y is 2 with 3. 2 with 3 squared plus 4 plus 2 arctan 2 y is 2 with 3 equal to x is 4. So from here, I think we can get our stuff. From here we have half ln 2 with 3 squared should give us 4 squared, 2 squared 4, 4 times 3 12. It give us 16. It give us 16. 4 squared, 2 squared 4, 4 times 3 12, 12 plus 4. That's ln 16 plus 2 arctan 2 cancel 2 arctan with 3 equal to ln 4 plus c. So don't forget that ln 16 will give us half, or 4 square ln 16. Okay, ln 16. Okay, I can have half ln 4 square plus 2 arctan of root 3. Arctan root 3. Let me check it. That would be in radian. Arctan root 3. That's 60, and 60 is 180 over 3. That's pi over 3. Arctan root 3 will give us pi over 3 equal to ln 4 plus c. This 4 square, 2 go to the back, became ln 4 plus 2 pi over 3 equal to ln 4 plus c. Ln 4 cancel ln 4. So the arbitrary constant is 2 pi over 3. That's the constant. Now we have the arbitrary constant. The questioner asks us to solve the equation. Solve for the value of x when y is 2. Solve for the value of x when y is 2. So let's substitute back the constant into this equation. So we have 1 over 2. Remember, you're looking for the value of x when y is 2. Let me confirm. Find x when y is 2. Okay. Y is 2. 2 squared plus 4. I'm using this equation that I've got before, plus 2 arctan. Y is 2, right? 2 over 2. We are looking for x. And our c is now 2 pi over 3. So we have half ln 2 squared 4. 4 plus 4, 8. Plus 2 arctan 1. Arctan 1. I'm going to get that equal to, I'm looking for x. Is 2 pi over 3. Arctan 1, what does it give us? Second function tan 1, 45. That's pi over 4, 180 divided by 4. Put your calculator in radian anyway. So this one, half ln 8, okay, half ln 8 should give us, okay, let me see, leave it, or let me leave it, or I can do just ln 8 raised to the power half plus 2 arctan 1 is pi over 4, input in the calculator, equal to ln x plus 2 pi over 3. So this is ln 8 raised to the power half. That's ln with 8 plus 2 pi over 4 give me pi over 2 minus 2 pi over 3 equal to ln x. So from here I have ln with 8 pi over 2 minus 2 pi over 3 pi over 2 minus 2 pi over 3. That will give me, like, can you see, 3 pi minus 4 pi over 6. That's minus pi over 6. I think it gives us something like minus pi over 6. Let me check it again. Okay, that's minus pi over 6 equal to ln x. So bring the ln like arrangement. Ln with 8 minus ln x equal to pi over 6. I'm very sure you are familiar with the rules. Ln with 8 minus ln x, it means ln with 8 over x equal to pi over 6. And ln with 8x, ln with 8 over x means log base e with 8 over x equal to pi over 6. From the definition of logarithms, so we have with 8 over x equal to e raised to power pi over 6. We are looking for x when it cross multiply. When it cross multiply, so we have cross multiply like this. So when you cross multiply, like I shown earlier, so that will be root 8 equal to x e raised to power pi over 6. Make x the subject of formula. X is root 8 over e raised to pi over pi over 6. So punch this in your calculator, or it's still the same thing like this, law of indices, which will give us 1.68. That's the value of x. I believe it's clear. Questions are welcome in the comment section. Number 9. 9 question. Vector equation of a line. We have two lines. Line L. Line L can be written as this, AI. Let me write in the column form. I prefer that. I first, J and K plus lambda I, J, K. That's line L, equation 1. Let me write M here. Line M. No, this is R, the position. The position for M. This is line L. And this is M. In column form, I, J, K plus mu I, J, K, equation 2. Line L and line M. Now, they said L is perpendicular to M. That's the first statement. Let me interpret this first statement. If the two lines are perpendicular, their direction, the scalar product of direction of M times direction of L must be equal to 0. This is the meaning of this statement. Direction of M, the one that have mu and lambda are the direction. The direction of M is 2 minus 3, 1. Dot direction of L, C minus 2, 4. The scalar product must be equal to 0 based on the statement of the line. At the end of the day, 2C plus 6 plus 4 equals 0. 2C plus 10 equals 0. C is minus 5. That's it. Now, let me now go further. P lies on L. Let me interpret that one too. P lies on L. Where is P? This is P. And P lies on L. If P lies on L, it means that P will now take position of R in L. That's the meaning. P will take position of R in L. What's L? You can see this is L. So this is L. What's our L? Our L is R equal, I need to write it. Is it 1, 2, 3? Let me check it. What's my L? No. This is M. 1, 2, 3. L is A3B. Okay. Our L is column A3B plus lambda C minus 2 and 4. I guess. Let me check. This is A3B C minus 2, 4. Remember I said P lies on L. When P lies on L, P will now take position of R. That's the meaning of lies. P will take the position of R. First, this is P. 4, 7 minus 2. Instead of writing R, you're going to write P equal to, let's do a little calculation. A plus C lambda 3 minus 2 lambda, and this one B plus 4 lambda. Okay, so okay, I think we can get lambda from here, from the last column. We can get lambda there. Minus 2 equal to B plus 4 lambda. No, we can't get lambda for this. So we can get lambda from the second column. So let me erase this. 7 equal to 3 minus 2 lambda. Sorry, you can get lambda from there. The constant 7 equal 3 minus 2 lambda. We have 4 equal to minus 2 lambda. Here, lambda equal to minus 2. So if lambda is minus 2, I think we can get B then. B is in the third column. That is minus 2 equal to B plus 4 lambda. So minus 2 equal to B plus 4 lambda is minus 2. So from here we have minus 2 plus 8 equal to B. So B here is equal to 6. So I can get A from the first column. The first column is 4 equal to A plus C lambda. 4 equal to A plus C lambda. Lambda is minus 2. C is 4 equal to A plus C is minus 5, right? If I'm not mistaken, C is minus 5. Minus 5 times minus 2 is plus 10. So 4 equal to A plus 10. From here, A should be minus 6. That's it. And the first question is find the value of constant A, B, C. I think we are done. I thought I wanted to manage space so I can use the other space before, but it's clear. Second question. 6 marks. The perpendicular from P meets M at Q. The perpendicular from P. Okay, let me draw something like a sketch. Perpendicular from P meet M. Meet line M at Q. Let's say this is line M. So a line is coming from P. It meets line M at the point Q. Point Q is the point on line M. That's the meaning. So R lies on PQ. You can see PQ. Between P and Q, R lies there. Let's say R is here, such that PQ ratio QR is 2:3. Is it here? Find vector R. Okay, I'm coming to that. But first, if you take your time, if you look at the diagram, what I can see first is that the whole of PQ is perpendicular to QM. That is the first thing I noticed. PQ is perpendicular to QM. I'm very sure you agree with me. And remember that Q lies on M. Q lies on line M. Q lies on line M. Q lies on line M. Remember the one we did earlier when they said P lies on L. Remember the way we did it. So this one, Q lies on M. You know, what is line M? Line M is R equal to, I think I have 1, 2, 3. Let me check it. Line M, 1, 2, 3, yeah. And mu 2 minus 3, 1. Okay. 1, 2, 3 plus mu 2 minus 3, 1. Since Q lies on M, Q will take the position of R. So OQ, which is the same thing as Q, will now be equal to this equation of M, which is 1 plus 2 mu, 2 minus 3 mu, and 3 plus 1 mu. That is the meaning of Q lies on M. Since Q lies on M, so OQ is this. Like I said earlier, PQ is perpendicular to QM. PQ is perpendicular to QM. What is PQ? I don't know PQ. Since PQ is perpendicular to QM, which means PQ dot QM will equal to 0. Now, what is QM? What is PQ? What is QM? Now, no. Sorry, PQ is not perpendicular to QM. PQ is perpendicular to M, to line M alone. Yeah, PQ is perpendicular to line M. Look at it. Look at line PQ. It's perpendicular to line M, or line M, not QM. It's perpendicular. I repeat, PQ is perpendicular to M. So the scalar product of PQ dot M is equal to 0. We know M. What we are using in M is the direction of M. It will be PQ multiplied by direction of M equal to 0. And what is PQ? PQ is OQ minus OP. That's how to get PQ. Then PQ, vector formula. What's OQ? OQ is 1 plus 2 mu. Remember the way we got OQ, because Q lies on M. Since Q lies on M, it takes the position of line M. That's how we got it. 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. OQ minus OP. What's OP? OP is vector P. And vector P from the previous question above is 4, 7, minus 2. That's vector Q. So at the end of the day, let's do the math to get PQ. So PQ is 1 plus 2 mu minus 4. I think I'm going to get 2 mu minus 3. 2 minus 3 mu, that's minus 5. Minus 5 minus 3 mu. This one will give us 5 plus mu. This is PQ. 5 plus mu. Sorry. 5 plus mu. This PQ. Now since, I'm going to repeat it again, since PQ is perpendicular to the line N as shown earlier. PQ is perpendicular to line N, so which means PQ is a point, is a vector point multiplied by M is a line. You are going to use the direction of line N equal to 0. So PQ is 2 mu minus 3 minus 5 minus 3 mu 5 plus mu dot direction of M. Direction of M, well, this is line M. The direction is 2 minus 3, 1. 2 minus 3, 1 equal to 0. So hence, when you multiply, open the bracket, that's 4 mu minus 6 plus 9 mu plus 15 plus 5 plus mu equals 0. At the end of the day, I have 14 mu plus 14 equal to 0. 14 mu equal to minus 14. Mu is minus 1. So since mu is minus 1, I can now get, let me divide the line. Since mu is minus 1, I can get PQ. So PQ will now be, PQ, since mu is minus 1, we can now get PQ. So, from here, this is 2 mu minus 1. Mu is minus 1. So this one will turn to minus 5. This one will turn to, I think, minus 2. This will turn to 4. Why OQ? Where is OQ? The one that have all the vector with mu. Since we have mu now, this one will turn to OQ. This one will be minus 1, 5, 2. And you substitute mu as minus 1 into it. So our PQ now is 5 minus 5 minus 2, 4. While our OQ is minus 1, 5, 2. These are the parameters we need to find vector R. Remember that the point R lies on PQ in this ratio, such that PQ ratio QR is equal to 2 ratio 3. Now, which means the path of PQ will be 2 over total ratio multiplied by the line they belong to. What's the line? Now the path of PQ, now the ratio is PQ to QR. The ratio is PQ to QR, which means the total line is PR. The total line is PR multiplied by PR. And also the path of OR, sorry, QR. The path of QR will be 3 over total ratio times the total line is PR. But the question asks us to find the vector R. Since PQ is 2 over 5 of PR, so PQ will be 2 over 5. What is PR? OR minus OP. So from here, and we are looking for OR. From here we have PQ equal to 2 over 5 OR minus 2 over 5 OP. So we are looking for OR, which is vector R. So So PQ plus 2 over 5 OP will equal to 2 over 5 OR. So at the end of the day, make OR the subject of formula. So to make OR the subject of formula, so OR will now be 5 over 2 PQ plus OP equal to OR. So equal to OR, yeah. So OR is R. So let's do it. 5 over 2 PQ. What's PQ? 5 minus 2, 4. What's OP? OP is P. That's 4, 7 minus 2. So from here, so OR, which is the same thing as vector R, 5 over 2 times 5 will give us 25 over 2. The other one will give us minus 5. While this one will give us 5 times 4, 20 over 2. We have 10 plus 4, 7 minus 2. So OR, when you add them together, this one will give us minus 17 over 2, minus 5 plus 7, 2, 10 minus 2, 8. This is the vector R the question asks us to look for. I believe it's clear and it's clearly explained. Let's see the next question. This partial fraction. Now, to express this as partial fraction, if you are following my channel, you know that this will be expressed as a over 1 plus 2x plus b over, it's called 1 plus b over 3 minus x plus c over 3 minus x squared. This is the rule when you have this kind of denominator. This is how you break it down. So at the end of the day, what's the LCM? The LCM is still the original denominator. So this is the LCM. So let's do the normal thing. The LCM in 1 plus 2x to give us 3 minus x squared multiplied by a. You have a 3 minus x all squared. The LCM in this, we have b 1 plus 2x 3 minus x. The LCM in the part of c is going to give us only c bracket 1 plus 2x equal. So this is what we've broken down. 21 minus 8x minus 2x squared over 1 plus 2x 3 minus x squared. It's been broken down to this. So this, we cancel out this. So what left is 21 minus 8x minus 2x squared equal to a into bracket 3 minus x all squared plus b into bracket 1 plus 2x 3 minus x plus c into bracket 1 plus 2x. Now let's find the value of a, b, and c. Now to find a, what is to find, maybe to find b or c. To find b or c, you must eliminate a and if you want to find c, you must eliminate a and b. To find b, a and c must be eliminated. How do you eliminate all these variables? Look at this one, the first one here. This is 3 minus x. This is the first one here is 3 minus x squared. Equate to 0. At the end of the day, x equal to 3. If x is 3, substitute x equal to 3 inside this function. So we have 21 minus 8 times 3 minus 2 3 squared equal to a 3 minus 3 all squared plus b 1 plus 2 times 3 minus 3 plus c 1 plus 2 times 3. You see that this one is be out, this one be out. So when you evaluate this, it gives us minus 21 equal to, this one will give us 7c. So c is equal to minus 3. Now I've made use of 3 minus x. Let me make use of maybe 1 plus 2x. Put 1 plus 2x 2. 1 plus 2x, put it to be 0. So x will be minus half. So substitute back to the function we derive or arrive at. That's 21 8 times minus half minus 2 minus half square equal to a 3 minus minus half all square plus b 1 plus 2 times minus half 3 minus minus half plus c 1 plus 2 times minus half. So when you evaluate this one will give us 49 over 2 equal to 3 plus half, that will be 7 over 2 square. That's 49 over 4. 49 over 4a. Why this one? 2 cancel 2. 1 minus 1 0. This one will give us 0. 2 cancel 2. 1 minus 1. This one is 0. So 49 cancel 49. So I have half equal to 1 over 4a. At the end of the day, my a will give us 2. Okay. So the next one, we have some space. Now we have a to be 2, c to be minus 3. We need b. To get b, this is what you do. 21 minus 8x minus 2x squared. Now I know a to be 2. Whenever I see a, put 2. And 3 minus x squared, expand it. That will be 9 minus 6x plus x squared. Do we know b? No. Expand what is beside b. 1 times 3 is 3. 1 times minus x is minus x plus 6x minus 2x squared. I think we know c to be minus 3. That will be, when you expand it, minus 3 minus 6x. Now just pick any coefficient, either coefficient of x squared or coefficient of x or constant. You're going to get the same answer. Let's try the constant. This is 21. Constant. What the constant here? I think is 18. What the constant here? I think is 3b. What the constant here? Minus 3. So 18 minus 3 is 15 plus 3b. So 21 minus 15 equal to 3b. 21 minus 15 I think is 6, right? 6 is equal to 3b. So from there, b is equal to 2. Perfect. So hence, if you pick coefficient of x also and do the same thing, you're going to get the same answer. Hence our a over 1 plus 2x plus b over 3 minus x plus c over 3 minus x all square has now become a is 2. 2 over 1 plus 2x. B is also 2. That's 2 over 3 minus x. C is minus 3. Minus 3 over 3 minus x squared. This is what they asked us to resolve into partial fraction. I believe it's clear. Now, hence, obtain the expansion in ascending power of x up to and including the term x squared p. So, this one, These are partial fractions. The answer we got here. So like this one, 2 over 1 plus 2x. 2 over 1 plus 2x. I'm writing as 2 over 1 plus 2x is per minus 1. And let me give you kind of a key, NB. I can use this. If you have something like this, a plus b over cx raised to power n. Okay, let me just give you this one. So it's equivalent to a raised to power n. Bracket. No, let me move c to be easier for me. It's same thing as a is per n, bracket 1 plus b over ax raised to power n. This is the same. This is key doing binomial expansion. You must, if you do your maths and rearrange this equation, you are going to get back this. Because doing binomial, the general formula for binomial, 1 plus x raised to power n, where n is negative or fraction, where n, which is the power, is negative fraction, will be 1 plus nx plus n into bracket n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed. This is the formula for binomial expansion where n is a fraction or negative, which you are about to do, provided that 1 is here. So we don't need to manipulate this, we are good to go. So this one will be 2, 1 plus nx, n is minus 1, x is 2x, plus n minus 1 over 2 factorial x squared. The question asks us to stop at x squared. The second one, which is this, 2 over 3 minus x. 2 over 3 minus x can be written as 2, 3 minus x, power of minus 1. Now we are going to use this manipulation. It's the same thing as, don't touch the 2's here. Like all I did there, if you follow it, it's going to give us 3 minus raised to power minus 1, 1 minus x over 3 raised to power minus 1, which is the same thing as 2 over 3 bracket 1 minus x over 3 raised to power minus 1. So we can now expand now. So we want to expand this 2 over 3, 1 minus x over 3 to the power of minus 1 using that same formula. The formula 2 over 3 is outside. Formula is 1 plus nx. N is minus 1. X in this case is minus x over 3. This is the one that take the x position, like this on x position 2x. I didn't put it there. X here is 2x. X here is 2x all square. Yeah. So 1 plus nx plus n minus 1 over 2 factorial x squared. X here is minus x over 3 all square. That's for this. So the last one, this one, minus 3 over 3 minus x squared, which can be written as minus 3 into brackets 3 minus x to the power of minus 2. You follow this pattern, this format here. Follow it. So we're going to have, this minus 3, let it be. So 3 to minus 2, 1 minus x over 3 raised to power minus 2, which is the same thing as 3 over 9, 1 minus x over 3 raised to power minus 2. 3 over 9, of course, is 1 over 3, right? 3 over 9 is 1 over 3. So let's expand that now. 1 over 3, 1 minus x over 3 all square. Let's expand it. So we have 1 over 3. That will be 1 plus n. N in this case is minus 2. 1 plus nx plus n minus 1 over 2 factorial. Why I'm stopping at minus 2 because minus a power of 2, the question asks us to stop at power of 2 all square. This is it. So these are the 3 expansions. This is the first one. This is the second one. This is the third one. So we're going to add them together. The question. Okay, let me see. That's the space. Okay, so I can flex a bit. The question is 2 over 1 plus 2x plus 2 over 3 minus x minus 3 over 3 minus x squared. The first one, which is 2 over 1 plus 2x, I think it gives us, when you open the bracket, 2 times 1, 2, 2 times minus 2x minus 4x. That's 4x. Do your math. Minus 1 minus 1 minus 2 over 2 factorial times 2x squared multiplied by the 2 outside. You're going to give us 8x squared. This is for the first expansion. For the second one, this is the second one. Open your bracket. 2 over 3 times 1. What do you have? 2 over 3. 2 over 3 times minus x over 2. That gives us, I think, minus 2x over 9. No, plus now. Plus 2x over 9. And the last one will give us plus 2 over 27x squared. The third one, make sure you open the bracket. You have the 1 over 3 times 1. 1 over 3. Is it minus? Oh, there's minus 3 outside there, so there's minus. Oh, need to pay attention. So here, there's minus there. Give us minus 1 over 3 minus 2x over 9 minus x squared over 9. Now this is it. So let's rearrange. 2 plus 2 over 3 minus 1 over 3. 8 over 3 minus 1 over 3. That's 7 over 3. Minus 4x minus plus 2x over 9 minus 2x over 9. Let's see. Sorry, minus 4x. 2x over 9 minus 2x over 9 is 0. Oh, it gives us minus 4x. The last one, 8x squared plus 2 over 27x squared minus x squared over 9. That gives us plus 215 over 27x squared. This is the expansion. Yeah. Okay, I believe it's clear. Number 11. Thank God, which is the last question. The complex number z is defined by z equal to this. Z is 5a minus 2i over 3 plus ai. The first thing you should do in complex number, once the denominator is complex, you need to rationalize. What did I mean by denomination is complex? There is imaginary number at the denominator. You need to rationalize. So z will be 5a minus 2i over 3 plus ai. The reason for rationalization is to eliminate the complex number at the denominator minus AI. Conjugate. You rationalize by using the conjugate, that's the opposite. So multiply this and this together. You're going to have 15a minus 6i minus 5a square I plus 2a I square over the bottom. That will be 9 minus a square I square. So at the end of the day, the complex number will give us 15a, because 15a I square, this I square is minus 1. So minus 1 times 2a minus 2a. This is minus 6i minus 6i minus 5a square I all over 9 minus a square. I square is minus 1. So z, 15a minus 2a, that's 13a. 13a. I is common. So the other 6 minus 5a square. So minus 6 minus 5a square over 9 plus a square. So at the end of the day, so z can be written as, we arrange 13a over 9 plus a square plus I into bracket minus 6 minus 5a square minus 6 minus 5a square over 9 plus a square. I've broken it down into complex number, real and imaginary. So this is x, this is what? Y. You have to break it down like that. And the question says that, look at the question. The question says that given that the argument of z is minus 1 over 4 pi, what is the formula for argument? Argument is arctan y over x. So in this case, the argument of z in this case, is arctan. Our y is minus 6 minus 5a square. The y is a part of imaginary. The x is the real that has no I. 13a over 9 plus a square. Close the bracket. So this cancels this. So the argument of z is now arctan. The argument of z is now arctan minus 6 minus 5a square over 13a. Over 13a. And the question asks us that, question says that the argument of z is minus 1 over 4 pi, which means that arctan minus 6 minus 5a square over 13a is equal to minus 1 over 4 pi, which is the same thing as minus 6 minus 5a square over 13a equal to tan minus 1 over 4 pi. So from here, this can be simplified as minus into bracket 6 plus 5a square over 13a. Tan of minus 1 over 4 pi will give us minus 1. So minus cancel minus. Cross multiply. 6 plus 5a square equal to 13a. We arrange 5a square minus 13a plus 6 equal to 0. That's turned to quadratic equation. So two factors are, that's 5a square minus 3a minus 10a plus 6 equal to 0. So a into bracket 5a minus 3 minus 2 into bracket 5a minus 3 equal to 0. From here, a is 2 and also a is 3 over 5. But the question said earlier that a, let's check it, there's a condition. Find the value of a and express z in form of x plus ij. Okay, that's the first one we did. To express z in form of x plus ij. We did that there. Z as x plus ij. The second one is a. Find the value of a. A is an integer. Since a is an integer, which means that the value of a, since a is an integer, which means that the value of a, since a is an integer, the value of a will be 2. This is rejected. So a is equal to 2. Great. Let's see the second question. At the end of the day, the answer will be in this form. The chefs express z in terms of x plus ij. Z will now be, so let's substitute a in z. So these are z before. These are z. These are z. This is our z here. So we put our a here in the one we express in x and y. So since a is 2, so 13 times 2 over, let's do it there. 13 times 2, a is 2 now. 13 times 2 over 9 plus 4 plus I minus 6. A is 2, that's 4 over 9 plus 4. At the end of the day, 26 over 13 plus I minus 6 minus 6 minus 20 minus 26 over 13. All you have 2 plus minus 2i. So z, the final answer for z will be 2 minus 2i. Okay, it should be that z. That's it. The last part, which is b. Okay, the last part, express zq in form of r e I theta. If you recall from the previous question, our z is 2 minus 2i. What is zq? Zq will be 2 minus 2i cubed. So 2 minus 2i times 2 minus 2i times 2 minus 2i. If we open a bracket, this 2 will give us 4 minus 8i plus 4i squared multiplied by 2 minus 2i. Okay, sorry. And I squared is minus 1. So this and this will go. So what left? I think we have 8i times 2 minus 2i, which will also give us minus 16i plus 16i squared. And I squared is minus 1 minus 16i minus 16. This is z cubed. Now, it said this form. You have to put it in this form. R e I theta. This R is the modulus. Sorry, single L. This theta is the argument. Now let's find the modulus first. Modulus of, I think I have space, okay. Let's find the modulus. Modulus of z cubed. That will be square root of minus 16 squared plus minus 16 squared. So modulus of z cubed, which is the same thing as r in that form, will give us 16 root 2. That's that one. Then let's get the argument. I need to sketch the diagram for the argument. You know, this is imaginary, positive, this is real, real negative, real positive, imaginary negative. And it's minus 16 to it's minus 16. Minus 16 to minus 16 is on this quadrant. So it's on this quadrant. The y part is 16. Then to put the negative. The negative just show you the quadrant it falls into. The x part 2 is 16. Then to put the, so this is the angle. So the angle, the opposite over adjacent. At the end of the day, we have arctan 16 over 16. Don't forget, you don't need to put the negative. The negative shows you the direction or the quadrant it falls into. At the end of the day, we have arctan 1, which is pi over 4. Now, each quadrant has negative. So to ask the formula. Now to now find the quadrant, sorry, to find the argument in this quadrant, the argument of z cubed in this quadrant, the formula is minus pi plus alpha in this quadrant. So the argument in this quadrant will now be minus pi. What's the alpha? Pi over 4. At the end of the day, the argument, which is also theta, is 3 pi over 4. That's the argument. So hence, minus 3 pi over 4 is minus 3 pi over 4. Hence, the expression of z cubed in form of r e I theta will be, our r is 16 root 2 e raised to power I theta, and our theta is minus 3 pi over 4. That's the answer. Thank you. Please share to your friends, like and subscribe. More content are coming. See you in a jiffy.